Practice for section 5.1. We're going to classify each triangle by its angles and by its sides. So really all we need to do is look at the angles. If all of the angles are the same, then we know that all the sides are the same, so we can consider that triangle equilateral. Now notice how all of the angles are less than 90 as well. That means the triangle is acute. So we'll call this an acute equilateral triangle or equilateral acute. Either one is fine. If a triangle is going to be equilateral, it must be acute. We cannot have an equilateral right triangle or an equilateral obtuse triangle. Those aren't possible. In number 2, we have a scalene right triangle because all of the angles are different, so all the sides are different, so it's scalene. And it's a right triangle because of the right angle. In number 3, we're going to have an isosceles obtuse triangle. It's isosceles because 2 of the angles match, so 2 of the sides match. It's also obtuse because 1 angle is bigger than 90. In number 4, we have an isosceles acute triangle. It's isosceles because 2 of the angles match. 2 of the sides match as well. All of the angles are less than 90. That's why it's acute. Number 5 is scalene obtuse. All of the angles are different, so all the side lengths are different. It's obtuse because 1 angle is bigger than 90. In number 6, it's isosceles acute. 2 of the angles match, 2 of the sides match. It's acute because all of the angles are less than 90. Number 7 is scalene obtuse. All of the angles are different. 1 angle is bigger than 90. Number 8, it's an equilateral acute triangle. Again, all of the angles are less than 90 and they're all the same. They're all 60. So equilateral acute triangles always have those 3 angle measures. This triangle is isosceles right. 2 of the angles match, that's what makes it isosceles, and 1 of them is a right angle. This is also the only isosceles right triangle possible, 45, 45, 90. On the bottom section, it asks us to make a sketch of each triangle. If it's not possible to sketch the figure, write not possible. Instead of actually sketching the triangle, we're just going to come up with the 3 angle measures. So if you want a right scalene triangle, one of the angles needs to be 90. The other 2 angles need to be different from each other and different from 90, obviously, if it's to be scalene. So here's a good example. 30, 60, 90. Now I know these 3 add up to 180, right? So these have to add up to 180, always. If that's 90, I know these have to be 90, so you just come up with 2 numbers that add to 90 to make it right scalene. So another example would be 20, 70, 90. They're all different. One of them's 90. Number 11, obtuse isosceles. You could go back to this top section and look for an example there if you're not sure what to do, but you need an obtuse angle, so I'll make it easy. We'll make it 100. That means you got 80 degrees left. And if it's isosceles, those other 2 angles better match. You obviously can't have 2 100-degree angles, so it's got to be the 2 acute angles that match to make it isosceles. Again, there's other examples here. I could have went with a 120-degree obtuse angle. That means there's 60 degrees left. So the other 2 would be 30. They would match and add up to 180 total. Number 12 is right isosceles. We already talked about this one. There's only one right isosceles triangle in the world. That's the only possible option. 2 of the angles match, 1 of them is 90. Right equilateral. If you have a right angle and all the angles are the same, then you'd have 3 right angles. That doesn't make a triangle. This is not possible.